Now this diagram is showing the same events which I have described in the last slide. This is the action potential in the SA node. Okay, and I have also labeled these phases. This is the phase 4, this is phase 0, and this is phase 3. Now this phase 4 is actually resting membrane potential, but this phase 4 is not stable. Okay, it is an unstable resting membrane potential, and this is also known as pacemaker potential, and this is unstable. As you can see that the negativity inside the nodal fiber is gradually decreasing till it reaches the level of -40, and this is because of the presence of the funny channels. And you see from these diagrams here, you can see that under resting conditions, at rest, okay, the outward potassium current is there, but at the same time sodium is also moving in, and slowly and gradually the inward sodium movement is gradually increasing. So there is gradual increase in the inward sodium current through those funny channels, through those leak channels, and the inside slowly and gradually becomes, the inside becomes less and less negative till it reaches -40. And at -40 the L-type calcium channels are opened. L-type calcium channels are opened, slow calcium channels that allows the calcium ions to go in, and the inside becomes positive, and this is depolarization of the SA nodal fibers, phase 0. But this phase 0 in this case is because of the opening of the voltage gated calcium channels and not because of the sodium channels, because I have already told you that at this low negativity of -40 the sodium channels have gone inactivated already. Their inactivation gates are closed so that they cannot contribute to this action potential. They do not have any role. Remember that the fast sodium channels do not have any role in the SA nodal action potential. Okay, so this phase 0 is entirely because of the calcium influx. At the peak of this action potential, that this peak, okay, when the phase 0 ends, the L-type calcium channels, the slow calcium channels are closed, and at the same time the potassium channels are open, and the potassium goes out of the potassium. You see the potassium going out of the cell, and the inside again becoming negative till it reaches this -60, the resting levels. But at this very point the voltage gated potassium channels are closed, and once again what happens that the sodium leakiness begins, and this sodium leakiness gradually increases till the resting membrane potential is gradually moves from -60 to -40, which is the threshold potential, and again it fires. So in the